Hello and welcome. This is Ajinkya. In today's video, we are going to learn how to create a WebGL project using BabylonJS and TypeScript. And you might be wondering why I suddenly started WebGL and game development. Well, I love game development, but at the end, the interesting part is Chrome released Web GPU support, which means you can create massive high performance games just for the browser. So let's get started. It's a really good time to start learning BabylonJS and WebGL. So I'm going to create a Babylon project using VITE CLI. Let's get started. And my node version is 19. I'm going to scaffold VITE via yarn. This is going to be a vanilla TypeScript project. And I'm going to choose TypeScript. All right, so just cd to that. Let's just see what we have. Cd to bjs that we created. All right, and yarn just to install basic stuff. All right, so you'll see we have some basic files over here. I'll just quickly run that and show you what we have. Oh, by the way, yes, I really don't like this port, so I'm going to modify this. And I already have a basic file just to do that. It's not much, just a simple white config file, VITE config file. Oh, where are you? Yes. So now we are going to use port 8080. Also, so quickly run that and just show you what we have. Somebody is already running at port 8080 and it shows 81. Okay, just to save time, I'm not going to go further digging what's running at what. All right, so now let's go ahead and create a basic project. So inside of index.html, let's just add a canvas. Okay, let's just give it app, it's fine. Okay, and go back to your main TypeScript file. I'm going to delete this counter.ts file. So we are just left with main.ts, and I'm going to remove everything from here as well, and remove all this except for this type. Okay, so we are just left with this much. To create our basic BabylonJS game, so this is going to be a simple setup, and later on let's see what we are going to create. But at least in this video, this is going to be just a kind of like a boilerplate base game setup for your BabylonJS game. In next video, we'll also deal with physics and also talk about what we are actually going to create. I mean, what game are we going to really create? All right, so anyway, so let's just create our first file. As I mentioned before, I'm going to create everything with object-oriented programming. So let's create our game class. Export default class game. Okay, so we have this with us, but we haven't added Babylon. So let's just add that. So yarn add at BabylonJS -core. I mean /core. And all right, so our game is going to have simple basic things. The most important one I would say is an engine type of, it's going to be a type of engine. The second part is going to be a scene, which is going to be a type of scene. And let's just add also a constructor. That's it. All right, so I think I like to keep the constructor as private so we can access it later on. Private. Okay, and yeah, this is what you need, but I'm going to create a scene with a different style. So I'm going to call it create scene, and which is going to return us a scene, which also needs to have an access to this dot engine. Also, I would like to create this create scene method as static. So public static create scene, so that we'll be sure that whatever we are going to create is just getting initialized, and this is create scene going to create things which are not going to change afterwards, which are not going to create which are not going to change afterwards. So it's everything that will not change during the game. Okay, so let's just return the scene. All right, so scene will have camera, light, materials. Okay, and let's also add some node. Everything that will not change during the game. Okay, good. Also, this, since we have made this static, it needs to be accessed like this, game.create scene. Okay, the also another important thing is you need to have a great game loop. So we are going to have it like this. Okay, so game loop is something like it runs 60 times each second. Okay, and perfect. So this is going to be this dot canvas. All right. Also, I think we need to have stretch this canvas like width 100% and height 100%. So I'm going to add that. All right. So this is all okay. Okay, let's initialize this game class. Import this, and I'm just simply going to copy this and paste it here. All right, and this is going to be a type of HTML canvas element. HTML canvas element. All right, so the error is because it might be null, so that is what it is crying for. But we have made sure that inside of index.html we have an app ID with a canvas. So let's just add a bank. So it tells TypeScript, yes, it not might be null, it will always be a canvas element. Okay, all right, so going back to the game.typescript file. Also, let's run this gamedev. Okay, here we have our canvas there in the screen. Ignore the styling, why it is in the center. We'll take care of this in the next video. For now, let's just let's just concentrate on having a basic scene. So scene will have a camera, and so I'm going to have also we are going to have lights. So let's just first create a camera. I'm going to use an arc rotate camera. All right, so let's import this, and I'm going to call this as just camera. Okay, so vector 3.0. Okay, so what all these values are, so this is the rotation. I like to keep it as 0. This is the horizontal rotation, and I'm going to call it pi by 3. And this is how further do you want it to be. I'll just keep it at 5. And so this camera, we need to, since we are going to attach control with the mouse, so of course, yes. But so when we are rotating with our mouse inside our canvas, we need to have some sort of limitations, how further you can go. So let's just call it 9, and same thing for the upper radius 9. All right, so if you look at now, it's working, but you cannot see anything because we don't have any objects yet. Let's also add lights before leaving this create scene method. So let's simply add some simple lights. It's not scene light, it's going to be a new hemispheric light. And so this vector 3 is kind of like direction that we wanted to have. Okay, and light is also going to have some intensity. We also will like to have some sort of ambient light, which is like ambient color. So scene, yeah, scene dot ambient color, which defines if you really need like a white color or something else. So you can play with these values, and we still don't have anything because we don't have any objects yet inside our game. So let's just call this function create scene. Yes, perfect. So as I mentioned, we need our first game object that is going to be our ground. So also we are going to follow a game with object-oriented concepts. So let's have game objects. Also, I'm not a professional game developer, so I might make mistakes. Please help me out with your comments on the video. So let's create a game object.ts file, which is going to be a mesh. So game object is actually going to be a mesh, which is going to be extended by other game objects. Export default class game object. Okay, and this is going to be extends mesh. Perfect. So we don't have to create basic things again and again. Okay. So it needs a name. It also needs game. It needs a game. Yes. Going to be type of game. Perfect. So now we have our game object, which extends mesh. I think super will need to have a name, comma, game dot scene. So this is where your any mesh objects gets added to this current scene, so that it gets displayed on your scene. And also let's define some private values. Game is going to be game, and oh, I made mistakes. Then we also need a scene. We actually really don't need this scene object because you can always say get scene, but let's still have it. Okay, let's initialize them. Perfect. And that's it. So cause of mesh, we'll have access to basic things like material, position, etc. Okay, so we have our game object ready. And why not create our first game object that is going to be our ground. Ground. In future, we'll have another class called level, which will create our base level ground. But for now, let's just have a ground. Export default. Perfect, which extends game object. All right, so our constructor is going to accept a game as well as some position. I'm going to pass X and Z. Why not Y? Because Y will be 0 by default. All right, so this is going to be, since this is extending game object, we need to call the game object constructor. So game object constructor needs the name. So in this case, it is going to be ground, and it also needs access to the game. Perfect. All right, and so this ground needs to have some sort of shape. In this case, I'm going to use a vertex data. The reason for that is, I'll also tell you what I mean by that. So I'll just call this vertex data is equal to create box vertex data. Yeah, perfect. So create box vertex data, which needs to have size 1. Perfect. Let's have it size 10, width as 10, height, this is perfect, depth also as 10. Perfect. So why vertex data, and why not just use a mesh creation, something like mesh builder dot create box. Wasn't it easy? Yes, it was easy. But the reason I chose this over uh, mesh builder create box was mesh builder will return you a mesh, but create box vertex data, of course, will create a shape with vertex data, but it will not create a mesh. So these are two different aspects. I would advise you to read that over the docs. But if you really need more explanation on this, please post it in the video comments. I'll happy to help you. Okay, so let's just add this vertex data to this current mesh so that this vertex data gets applied to this mesh. Okay, and material, yes, we are going to need a material, but we'll deal with material later on. For now, let's just add a position, and this position is going to be vector3.0. Yes, we are going to initialize it to 0. That's why I said we don't need y value. We just need x and the z. Perfect. And that's it. So let's see if this is there inside our scene or not. Okay, I'm reloading, it's not there. The reason for that is we haven't added that to the game yet. So I'm going to call this function as for adding basic game objects. I'm going to call this function called init game. Okay, and init game is a function which is like basically everything that will change during the game. Perfect. This worked because I added this. Everything will not change during the game. Okay, perfect. So init game will have things like player, okay, level. Okay, in this case our level is our ground, and let's just initialize that. You can, if you want, you can save the ground object over here as a private property, but as of now we don't need anything to be saved inside game. In future we will have a level class, but for now let's just initialize the ground. Okay, so let's just import this. And you might be wondering why I said this, because this is referring to the game class. And if you notice, our ground class constructor needs a game access. Okay, perfect. And the x and z values are 0. And let's see if it's there. It's still not there. We forgot to call this function. Okay, this is going to be this dot init game. Perfect. All right, it's there now. Now you might be wondering how come this got added over here? If you remember, we created a game objects class which creates the mesh and also adds it to the current scene. See, we save few lines over here. All right, so that's it from the ground. Let's move on to create a player now. For now, our player is just going to be a block, but still we are going to call this as player.ps. And this time we are going to save information about our player over here, which is going to be class of player. Okay, and let's just create that player. Export default class player. Okay, which extends game object. Perfect. So our player is going to have simple properties in future: direction, rotation, body for the physics imposter. So yes, of course we are going to have physics, but not in this video, next video. For now, all we need is just a constructor for now, just to get this guy rolling. Okay, super player, cause we need to extend the mesh, and perfect. So the position, this dot position is of course again going to be vector3.0, and let's just increase the position of the y height so that you can see it in the view. Okay, perfect. Okay, you might have already guessed, we forgot to create our vertex data. Const vertex data. This time I'm not going to use create box vertex data. Let's create something spheric, sphere, icosphere, create ICO sphere data, vertex data. Perfect. And it won't need this properties. It will need radius and yeah, subdivisions. Subdivisions, we're going to have 3. Radius, we're going to have 0.5, like a small sphere. And just apply this to the mesh. That's it. Let's just call this player into our game now. Okay, and inside the init, this dot player is equal to new player. Perfect. Here we have it. Okay, so that's it from this video. I hope you enjoyed this first video, and I really hope you're excited for this game development series, which I'm going to use BabylonJS. I chose BabylonJS over 3JS is because I really feel BabylonJS is like a full-fledged game engine. 3JS is just a rendering engine. And please subscribe to my channel and like my videos. Don't forget to comment on my videos as well. Thank you. Bye bye.